3 tapilla. Good evening, my dear students. Welcome to HashLearn Studios. My name is Dheeraj and I'm your chemistry teacher for the day. And the topic under discussion is Lanthanoids, part of D&F block, and it belongs to JEE and NEET lecture series. So moving ahead, in the previous class of mine, we had looked at some of the important transition elements and numerical problems pertaining to transition elements. And taking this lecture a little ahead, let us quickly look at the CPP question which I had picked up from the previous list of CPP questions that I had given to you. Let's read the question quickly. So we have Yogesh joining us as the first participant. Welcome Yogesh, welcome to the webinar. Which one of the following sets correctly represent the increasing in the paramagnetic property of ions? It's fairly simple. Higher the number of unpaired electrons, higher is going to be the paramagnetic behavior. So if you check the trend as to where it is going to have highest number of unpaired electrons, it is going to be in the case of manganese, followed by chromium, then vanadium, and then copper. Straight away we have the answer, which is option C. So we have Preeti Baghel also joining us. Welcome to the webinar, Preeti. Let us get going, guys. Like I said, the goals of today's class is to look at lanthanoids and questions pertaining to lanthanoids. I'm not just going to restrict my understanding and questions to lanthanoids. We will look at some of the other important questions of a little previous topics as well, so that you get an overview of all of this. And lanthanoids, like I said, I look at it cumulatively, guys. I give questions from the current topic, include a couple of them from the previous concept, and that will go up till the last I would say lecture, so that you will have a complete overview of the entire topic. Moving ahead, let us quickly say the next slide you would be seeing is the first question for the day. So here we go. Read the first question, guys. The radius of La3 plus, La stands for lanthanum. The radius of lanthanum 3 plus, whose atomic number is given, is 1.06 angstrom. Which one of the following given values will be closest to the radius of lutetium, whose atomic number is 71? So you have 1.4 angstrom, 1.06 angstrom, same as that of lanthanum, 0.85 angstrom, and 1.6 angstrom. Which one is it going to be? Yogesh and Preeti, go for it, guys. Shouldn't take us too much time. These are questions wherein you can save a lot of time. Clock master says time's up. Quickly, guys, quickly. Yogesh says it's 1A. Let us wait for Preeti as well. What does Preeti say? I think if you're working from your end, let me help you. It's fairly simple. You can answer this in two ways. One, proper quantitative answer. The other one is qualitatively. Now I know that lanthanum is the first element and lutetium is the last element. So it's talking about the first element as well as the last element in the lanthanoid series. So as you know that as we proceed from lanthanum to lutetium, there is something called as lanthanoid contraction taking place. That is, the size of the ions or the elements goes on decreasing. As the size decreases, obviously the radius also has to decrease. So obviously it has to be less than, lutetium has to be less than that of lanthanum. So straight away I can look at it. This is more, this is same, this is more. If it is less, it has to be option C, which is 0.85 angstrom. This is how you can arrive at it in a very simple qualitative manner. If you want to qualitatively find out, we have a relationship, guys. That is, radius of 1 divided by radius of 2, it can be any two elements, is equal to the atomic number of 1. That is atomic number of 2 divided by atomic number of 1. So if I want, let us say lutetium is R2, atomic number, radius of the second element is equal to R1 into Z1 by Z2, which is going to be 57 divided by 71 into 1.06, which will exactly give you 0.85 angstrom. So if you have time and if there is a question pertaining to exact answer is asked, you can go to this method. If not, you can just say, I know due to lanthanoid contraction the size has to be small, therefore I will choose a size lesser than 1.06 angstrom. Both the ways you can answer this question. Hope you have understood, guys. Moving ahead to the second question. Quickly read the options. Consider the following statements. Lanthanum hydroxide is the least basic among hydroxides of lanthanoid. Zirconium 4+ and hafnium 4+ possess almost the same ionic radii. Ce4+ can act as an oxidizing agent. Which of the above is or are true? Think about it. Which of the above is or are true? 10 seconds left, guys. Clockmaster says time's up. Yogesh, Preeti, have a say on this. Let's say quickly. Let me know what your answers are. We will discuss after that. Lanthanum hydroxide is the least basic. Okay, Yogesh says it's 2A. Yogesh, no, it is 2B. Lanthanum is the least basic among hydroxides of lanthanoid. No, it is the most basic among hydroxides of lanthanoid. So this option is wrong. Zirconium and hafnium almost has the same ionic radii. That is right. It is true, universally accepted. And Ce4+ can act as an oxidizing agent. This is also true. Therefore, option B, option 2 and 3 is right, which makes it option B. And why does Ce4+ act as a very good oxidizing agent? We have Ce4+ acting as a very good oxidizing agent. You should know what is the work of an oxidizing agent. If I have to oxidize somebody, I should be taking electrons, correct? So once I take electrons, now Ce4+ can take electrons to convert itself into Ce+3. So Ce+3 is one of the most stable electronic configuration when it comes to lanthanoid. So it can quickly take an electron. By taking an electron, it is helping somebody get oxidized. Therefore, Ce4+ can act as an oxidizing agent. So I've given you the reasons behind all of these. We have Rakesh joining us. Namaskar Rakesh, and welcome to the webinar. Let's get going, guys. Let's get going. Move on to the third question. The third question is, knowing that the chemistry of lanthanoids is dominated by its +3 oxidation state. I just told you that. Which of the following statements are incorrect or is incorrect? The ionic size of lanthanum 3 decreases in general with increasing atomic number. Ln3 compounds are generally colorless. Ln3 hydroxides are mainly basic in character. That's lanthanum, is talking about lanthanum. Lanthanoids, okay. Because of the large size of lanthanoids ions, the bonding in its compounds is predominantly ionic in character. So read the points slowly. You'll be able to definitely give us an answer. Think about it. So Clockmaster says time's up, but no worries, guys. Understanding is more important. So read through the options carefully. The ionic sizes of lanthanum decreases in general with increasing atomic number. Lanthanum, that's generally lanthanide compounds are colorless. Lanthanide hydroxides are mainly basic in character. Because of large size of lanthanum ions or lanthanoid ions, the bonding in its compounds is predominantly ionic in character. So what is it going to be? So Yogesh says it's 3D and Rakesh says it is 3B. Yes, Rakesh has straight away joined in to give us the right answer. Good. Guys, this is right. Ionic compounds of lanthanoids decrease with increase in atomic number. It's correct. That's why we call it as lanthanoid contraction. Lanthanum compounds are generally colorless. No, they are colored because they have partially filled orbitals, which lead to electrons moving from F subshell to F subshell. It's called FF transition. So due to FF transition, electron excitation and return, the compounds appear colored, and that is due to the partially filled orbitals of lanthanoids. And lanthanoid hydroxides are mainly basic in character. This is also right. You know that their basicity decreases as we move. Because of the large size of lanthanoid ions, the bonding in its compounds is predominantly ionic in character. This is also right. And as we move across the periodic table, the ionic character decreases and covalent character increases. This is also right. So option D is the incorrect statement, and I've given you which is the correct statement, guys. Let's get going. This is the question. Here I don't have to tell much. If you know the 14 elements or the 13 elements involved in the Lanthanoid series, you will be able to give the answer instantaneously. So go for it. Which one is it going to be? So think, recall all the elements, and then you'll be able to give the answer. Ce3 plus, La3 plus, Pm 3 plus, and Yb 3 plus. Cerium, lanthanum, praseodymium, and ytterbium. Which one is it going to be? Quickly. Which one is it going to be? Yogesh says it is B. Okay. Let's wait for Rakesh also to give us the answer. Meanwhile, I'll write the elements, guys. Lanthanum, cerium. No, it's option A. Lanthanum, cerium, praseodymium, neodymium, samarium, that is promethium, samarium, europium, gadolinium, terbium, diosporium, holmium, erbium, thulium, ytterbium, and lutetium. This is how it goes, guys. Quite simple. I know it takes a little effort from your end, but remember it, you'll be able to answer Y. So as I move across the periodic table with respect to D block elements, F block elements, that the size decreases due to lanthanoid contraction. So what comes first? Lanthanum comes first, then what comes? Cerium comes, after that it is Pm, and after that it is ytterbium. So option A is the right answer, and the only key is to remember all of these elements, and once you learn the elements, it becomes easier for you. Now a little breather for you guys. A metal gives two chlorides A and B. A gives black precipitate with NH4OH, and B gives white precipitate with Ki. B gives a red precipitate soluble in excess of Ki. A and B are respectively. So this was the contest question that we had asked in the previous class of mine. So the previous class of mine was last Friday, and so after a good number of days we are meeting. Glad that you guys have joined me, and yes, this question was or is an important question, guys, and we had a lot of them giving us the right answer, and it was Peru who gave us the right answer fastest. So congratulations, Peru. So even though Peru is not joining us, Peru has been consistently giving us some of the right answers. So congratulations to you once again, Peru. You have won yourself an atom session, which gives you exclusive right to get one of your question or a concept answered by our in-house experts within 20 minutes of posting the question. So the next slide that you would be seeing is, guys, Rakesh, Yogesh, and we had Preeti also joining us. Look at it. The next question, the next slide would be the current classes contest question, which gives you an opportunity to win an atom session, guys. Go for it. Here we go. Okay, good. So Rakesh and Peru has given us the answer. X and W, we will know about it in the next class of mine, which is on Tuesday, guys. So here we go. Look at the fifth question assigned for the day. The fifth question is, which of the following oxides does not dissolve both in dilute HCl and NaOH? Pretty straightforward question. Which of the oxides does not dissolve both in dilute HCl and NaOH? That is, it does not dissolve in acidic medium, nor does it dissolve in basic medium, is the question. Which one is going to be? So quickly, scandium, copper, titanium, niobium, copper, silver, and gold. So which one is it going to be? Yogesh says it's 5C, copper and silver. No, guys, it is copper and silver and gold, because those are noble metals, and noble metals are the least reactive when it comes to reactivity. So it has to be gold and silver. In case gold is not there, then the right answer would have been probably copper and silver, because it is very low in the reactivity series, but below that is gold. So it is option 5D, wherein gold and silver are noble metals and hence their oxides will not dissolve both in dilute, acidic and basic solutions. Moving ahead to the sixth question. Amongst the following, the most ionic and basic compound is? The most ionic and the basic compound. This again tells you that higher is the ionic character, better is the basicity. That is the point to be remembered. So which is the most basic, and that is, which is the most basic, thus the most ionic, or which is the most ionic, thus the most basic. It can be consequences of both. Cr2O3, CrO3, CrO, CrO2. Which one is it going to be? Think guys, think. Which one is it going to be? Clockmaster says time's up. Sixth question, waiting for your answer. CrO. Yes, Yogesh gives us the right answer first. Rakesh, waiting for your answer. CrO is the right answer. The logic is fairly simple. Lesser the oxidation state, lesser the oxidation state or oxidation number of the metal, more basic is its oxide. So higher the oxidation state, there's a good chance that higher will be the covalent character, and higher the covalent character, smaller the compound, less will be the basicity. So it is related to oxidation number. Yes, Yogesh gave us the right answer first and then changed, but I hope you guys have understood, guys. Lesser oxidation number, more ionic character, larger size, higher basicity. I'll repeat that for covalent. Higher oxidation number, more is the covalent character, smaller is the size of the compound, lesser will be the basicity. So that is the order. Keep that thing in mind, guys. Quite an important question. Talking about seventh question picked up for the day. Pick out the correct statement of the following. The stability of either of mercuric chloride and tin chloride is not affected when present simultaneously in aqueous solution. Both CuOH twice and FeOH twice are soluble in aqueous NH3. Copper 1 salts are not known in aqueous solution. That is, copper 1 salts are not present. Either they dissolve, either they precipitate or they are insoluble. While precipitation of ZnOH twice, on adding excess of NaOH, we get, so they're trying to tell us that we get ZnOH twice on adding excess of NaOH to aqueous ZnSO4. So read through it once again. Let me know what is the answer. So stability of either HgCl2, Yogesh says C. Stability of either HgCl2 and SnCl2 is not affected when present simultaneously in aqueous solution. They're right, because they're completely two different species, so they will not interfere with each other's dissolution process or in hydration process, so it remains unaffected. CuOH twice and FeOH twice are soluble in aqueous ammonia. That is also right. We don't have to write the reactions in this case. Copper 1 salts are not known in aqueous solution. Copper, this is also right. As in, I'm telling you that when he's asking us to pick the right question, this is right. Statement is incorrect. Therefore, the options are right is the meaning, guys. So this statement is right. Copper 1 salts are not known in aqueous solutions. Yes, they are not known in aqueous solutions because if you take copper 1, it will disproportionate. You should know what is disproportionation. Disproportionation is the same ion undergoing oxidation as well as reduction. So it will disproportionate to give you Cu, which is a solid, that is reduction, or it will undergo oxidation to give Cu2 plus, which will dissolve in water. So Cu plus will always disproportionate to Cu and Cu2 plus. So this is correct. And while precipitate of Zn, no, this is also wrong. It doesn't give us these reactions. So which is the correct statement? Option C is the correct statement. Moving ahead to the 8th problem, guys. FeCl3 solution. This is an answer. This is a normally asked question, and this is answer to one of the practical problems of preparing solutions in a laboratory as well. FeCl3 solution is acidic due to hydrolysis. So if you take FeCl3 solution, you would have prepared that from FeOH thrice as well as HCl. Now you should know HCl is a strong electrolyte compared to FeOH thrice. Therefore, the solution has to be acidic. You'll study all of these under salt hydrolysis of equilibrium chapter. Quite important. From that aspect, you should know that it is acidic. Then how do we prepare neutral FeCl3 solution? Why is neutral Fe3 solution needed? Neutral Fe3, he himself has told us that it is needed for testing acetate ions. And apart from that, another important question is to check the presence of phenolic groups. You need neutral ferric chloride solution. So how is it that we prepare neutral ferric chloride solution? Because ferric chloride is basically acidic in nature due to the presence of HCl. So what is it going to be? What is it that is the answer? Straightforwardly, Yogesh has given us the right answer. It's simple, guys. First, you have to add NH4OH, that is ammonium hydroxide or ammonia, to FeCl3. It will start forming reddish brown precipitate. Then add more of FeCl3. The precipitate dissolves. Now the FeCl3 solution that you have is neutral. So I can say add a few drops of dilute ammonia to FeCl3 till the brown precipitate formed. See this? Yes. Add this, you start getting brown precipitate. Then again you start adding a little FeCl3, the precipitate dissolves, and therefore the solution that you get, which does not contain precipitate, will be neutral in state. So quite an important question. Remember it, guys. Moving ahead to the 9th question packed for the day. Which of the following pairs have both the elements showing highest oxidation state equal to Ns plus N minus 1d electrons? So if Ns plus N minus 1d electron is not making sense, you just have to see which pair has the highest oxidation state. That should answer the question. Quickly, 18 more seconds left. Highest oxidation state. You don't have to think so much, guys. Clockmaster says time's up, but no worries. Take a couple of more seconds. Try to give me the right answer. Yogesh says it's C. Yes, it is indeed chromium and manganese. Chromium forms a maximum oxidation state of +6 and manganese forms +7. So you don't have to worry about this. This talks about 3D elements, but you should know it is chromium and manganese just based on their rough atomic number or electronic configuration. So Rakesh, let us know what is your answer and let me know if there's any concerns about the question wherein I can help you with it. Meanwhile, moving ahead to the 10th question. Try to answer this question, guys. It's based on a structure, so take your time, look at it, draw the structure, and then try to analyze the question. Take a little time, no worries. What is it going to be? In case of Fe, iron carbonyl, the two iron atoms are, is talking about the linkage, linked directly, along with three CO molecules as bridging ligands or ligands, linked only through three CO molecules as bridging ligands, and joined through one CO group as bridging ligand. So this can be answered only when you know the structure of the given iron carbonyl, Fe2CO9. So which one is it going to be? Think. Meanwhile, while you're answering, I'll try to draw the structure so that it helps you in understanding the overall structure involved. So you have Fe, so this is how the structure would be, guys. So you have 9 carbonyl groups. Once you have 9 carbonyl groups, you can count. So what is it going to be? I think I drew one extra. Just give me here. Yes. Now you'll have it right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbonyls and 2 iron. And you can check. Iron is forming how many bonds? 1, 2, 3, 4, 5, 6. And it will form another bond with this. So iron has 7 bonds. Okay. So according to this, the answer has to be linked directly along with 3 CO molecules as bridging ligands. So these are the bridging ligands, guys. These are the bridging ligands. So both of them are bridged by 3 carbonyl ligands, apart from a bond being present between iron and iron. So option B is the answer. Remember the structure. These questions can be answered only if you remember the structure. So moving ahead to the 11th question. So just a couple of more questions packed, guys. So give it your best shot. An iron piece treated with acidified KMnO4. So this is pretty straightforward. You can give it a try. An iron piece treated with acidified KMnO4, what is going to happen? It is going to displace copper from dilute H2SO4, liberates hydrogen from dilute H2SO4, displaces copper from copper sulfate solution, not liberate H2 from dilute H2SO4, neither displaces copper nor liberates H2 from dilute H2SO4. What is it going to do? So think about it. An iron piece treated with acidified KMnO4, what is going to happen? So clock master says time's up. But think, guys, think what's going to happen. Yogesh says 11B, liberates hydrogen from dilute H2SO4. That's a good try. But remember, the moment a piece of iron or iron in general is treated with concentrated H2SO4, I'm sorry, concentrated HNO3 or acidified K2Cr2O7 or acidified KMnO4 or hydrogen peroxide. The moment iron comes in contact with any of these, iron becomes passive. Iron becomes passive due to a layer of oxide or the respective insoluble precipitate or insoluble compound getting formed on the iron surface. So once iron is completely forming a surface, once a insoluble precipitate is forming a completely covered surface on iron, iron cannot come in contact with any of these. If iron doesn't come in contact with any of these chemical, so it will neither be able to displace copper nor will it be able to liberate hydrogen. So the answer is option D, neither displace copper nor liberate hydrogen, because the iron which we are dissolving is not even coming in contact with these things. Why? Because it is forming an insoluble layer. So what iron on reaction with what all will lead to the formation of those insoluble layer around it? These are the compounds. The moment it comes in contact with these, it forms a layer which doesn't let iron dissolve further or react further. So that is the answer, guys. So move on to the 12th question that we have packed for the day. So look at the 12th question. It is relating to magnetism, that is spin magnetism and paramagnetism. So what's the spin and what is the magnetism? So have a look. So total spin and paramagnetism of ferrous. Ferrum is telling iron in +2 oxidation state. So iron in +2 oxidation state is going to be what? So quickly go for its electronic configuration, calculate the number of unpaired electrons. Once you know the number of unpaired electrons, you'll be able to calculate very easily what the spin and the total paramagnetism is going to be. So what is it going to be? So Yogesh says it is B, option B. Clockmaster says time's up. So we will start working from our end. So iron 26, 3d6, 4s2 is the electronic configuration. He says it's in +2 oxidation state. So its electronic configuration will become 3d6. If it is 3d6, it will have 4 unpaired electrons. If it has 4 unpaired electrons, you have partially got the answer. So the formula to calculate paramagnetism, it is n into n plus 2. So it is going to be 4 into 4 plus 2, that is 4 into 6, which is square root of 24. So where do we have square root of 24? This, and spin is 2. Option C is the answer. Yogesh, it's a pretty straightforward question. Should not trouble you so much. You just have to calculate the spin and the paramagnetism. So oxidation number of Fe is 2. So the total spin refers to oxidation number, and that is 2 in this case. And using that, I'll calculate the number of unpaired electrons, and paramagnetism is 24 Bm. Bm stands for Bohr magneton. So option C is the answer. Moving ahead to the last question that we have packed for the day. Have a look at it. This is also based on, again, the important magnetic property. Paramagnetism of chromium, manganese 2 plus, and ferric ion, that's Fe3 plus, are X, Y, and Z. They've designated alphabets for it. They are in the order. So they've given you equal to, greater than, equal to, smaller than. So you have to check. Again, magnetism or paramagnetism directly proportional to the number of unpaired electrons. So you can have a look at it and give me the answer, guys. Just have to work it out the way I worked out for the previous problem. Then you can answer it pretty straightforward. Clockmaster says time's up, but no worries. I can give you a couple of more seconds since it's the last question. Go for it. So chromium, electronic configuration, atomic number 24, electronic configuration 3d5 4s1, Mn plus 2. Again, it is 3d5 4s2 for Mn. If it is Mn2 plus, it is 3d5. Iron, it is 3d6 4s2, and if it is iron 3 plus, it's going to be 3d5. So how many unpaired electrons in chromium? In chromium, I'll have 6 unpaired electrons. In this case, manganese, I will have 5. In case of Fe3 plus also, I will have 5. So Peru has joined us for the last question. So Peru says it is option D. Yes, he has joined us with the right answer. Yogesh also says it's option D. Yes, guys, X greater than Y. X is for chromium. Chromium is 6 electrons. Yes, it is greater than 5 for manganese, which is equal to 5 for iron. So option is for 6, 5, 5, which is nothing but X greater than Y equal to Z. So good. I'm happy that you could, the two people could give us the right answer in this case. Okay. To quickly summarize, what we have done today. We looked at some of the propertical aspects of lanthanoids and some chemical reactions to do with lanthanoids and other compounds, and also the magnetic properties involving D and F block elements. So that was today's primary most concern. In the next class of mine, which is on Tuesday, we would have, for your convenience, we have packed 2 classes back to back so that you'll get a holistic approach of the pending lectures. So in the Tuesday's class of mine, which we are going to have, like I said, 2 sessions, we will be winding up actinoids and the remaining aspect of D and F block. So you're going to get a complete overview of that in the next class of mine. And you know the drill, guys. If you have liked the class, I'm quite sure you have liked it. If you have liked the class, go ahead and share this video among your friends and help them as well. And people who have subscribed to Passport CPP is unlocked. Go ahead and solve the questions immediately within the heat of the moment. So that gives you a better chance of impregnating all of these thoughts into your minds better. And apart from that, people who have not subscribed to Passport, guys, it's just a click away, and I'll tell you what that click is going to give you. That click doesn't just give you access to CPP questions, it also gives you access to 24/7 one-on-one doubt solving sessions, practice questions and tests from some of the best-selling books, and most importantly, all the video classes covering the toughest concepts and problems, which becomes a definite prerequisite as your JEE exams are approaching. Till the next class, which is on Tuesday, it's your chemistry teacher Dheeraj signing off. Good night, guys.